Welcome to this second part of lecture 2. We are going to take a look at a few more graphs. There are certain graphs which are not really used a lot in practice. Of course, you have it in some textbooks. We will not waste our time on it, but we will go directly to what we call a pie chart. A pie chart is a circle is divided into different sections. That's what we are going to be using for a pie chart. So without getting into the theory, let's take this example. So take a look at this. You have some categorical data, okay? You have different categories. It's of type nominal. You have nominal data set. For example, you have associate, bachelor's, master's, first professional, doctoral, and these are the frequencies. You take a sample, and these are the frequencies for each of the different categories. So when you have this type of data set, you can use a pie chart. It's very easy to use a pie chart. So you have the type of degree, you have the different frequency. You can as well compute the relative frequency. Now, how do you compute the relative frequency? If you add all of this, for all of the different types of degree, it ends up being 3007. Then you just divide each by the total. You divide the frequency by the n, the sample size, and it gives you the relative frequency for everything. And using that, you can generate your pie chart. However, you can move on to another level where you compute what we call here we are going to basically call it the central angle. And in order to compute the central angle, you know that a circle has 360 degrees. So simply what you do is you multiply the relative frequency by 360, and it's going to express it in angles. Generally, we don't do this by hand. We use a computer software like Excel, but here we are going to look how to compute it. Just multiply each of these by 360, and you'll have all of that, and you can now proceed to draw your pie chart, and that will be it. Now we are going to move on to the next part, which is known as the measures of central tendency. Measures of central tendency in the sense that you are searching for the central location. You are looking for the average location. Where is the midpoint of that data set? What do you expect to find, as some will call it? Let's start with the most commonly used ones. You have the mean, median, and mode, and we are going to be talking about that. The mean is also known as the average. So here you have the population mean. It's expressed using what we call mu, and you have the sample mean. So in other words, this is a parameter because you are computing the mean from the population data, and this is a statistic because you are computing the mean from a sample data. So it's important to be able to distinguish between the two. This is the population mean, this is the sample mean. So this is known as a parameter, this is known as a statistic. So let's move on. This is the first example. You have your data set, you want to compute the mean. All you need to do is to make sure you count the number of data points or your sample size. In this case, the sample size is 7. So for the mean, you add all of the points and you divide it by the sample size, so by 7, and that will give you your mean value. It's very important for you to be doing these things so that you really get comfortable, but in real life, we use a software package like Excel to do it. Now let's compute the next one, the median. Now the median, there are 2 steps involved. The first is you must order your data. You must put it in ascending order of magnitude or in descending order of magnitude. That's the first thing. The second is you want to count the number of data points. If you have an odd number, then there is an approach to do it. If it's even, there is a different approach. In other words, if for example your sample size is, let's say, 7, that's an odd number. If it is 6, you have an even number. So for each of these, you have different approaches, but you must start by putting your data set in ascending order. It must be ordered, else you cannot really compute the median. You will be doing something strange. Let's take the first example. So the first thing is to order this, and when we've put it in order, we count. If you take a look here, we have 2, 4, 6, 7. So we have an odd number, and when you have an odd number, here for example, we have 7, it means the middle score will be number 4. But for us to know which is number 4, this will not necessarily be it. We first of all need to put it in ascending order. Here we order the data set from, well, in ascending order of magnitude. Once you do that, you can immediately find that your middle score is this. This is number 4 because we have 7 data sets, and your median is this. Now let's take the case where we do not have 7, where we have an even number of data points. Here, for example, we have 6. So we will start by ordering it. When we put it in ascending order, after doing that, we do something beautiful. You take the 2 middle scores, because here you have 2 middle scores and you just look for the average. This is what we are talking about. Here you have the 2 middle scores after putting it in order, and you take the average, and that will give you your median. So remember, for the median, you have to make sure if it's odd, you pick the middle score after putting it in ascending order. If it is even, then you need to take the average of the 2 middle scores after putting your data set in ascending order of magnitude. Now let's take the mode. The mode is simply the score that occurs the most often. In other words, the data entry with the greatest frequency. Let's take an example. Now, there are cases where you have more than 1. If you have 2, it's bimodal. If you have more than 2, and so on. So here, for example, the first thing is to order it so that we can see scores that occur more than once. So for example, well, there are cases where you don't have any mode, when everything occurs only once. Then you have a problem. Here, let's order it. We order this data set here. Once you order it, you are looking for scores that occur more than once. And once you do that, you will see that this occurs twice. Meanwhile, all the other ones occur once, which simply means the mode is this particular of this data score. Why? Because it occurs the most frequently. This is your most frequent score, or your most popular. Let's take this example. Here it says a political debate, blah, blah, blah. What is the mode of the responses? So you are simply looking for the political party having the highest frequency. And if you look in terms of the highest frequency, you can immediately see that the highest is basically 56. So you are talking of this. Okay, the next one, we want to compare between mean, median, and mode. We want to do a comparison. Why are we doing a comparison? Because we are trying to look which metric we should be using to find the central tendency, or to look where is the middle part of this data set. Where is it? So it says which measure of central tendency best describes a typical entry of this data set. Are there any outliers? Now, the first thing is to arrange this in ascending order. Once you arrange it in ascending order, then you are able to do your computation of the median and mode. For the mean, you really don't care. You just add it and you divide by the number of, or by your sample size. That's what you have. Your median, once you arrange it in ascending order, you will find that, first of all, you are dealing with the sample is even. So you'll take the 2 middle score and you'll look for the average. This is your median. And the mode, if you are looking for the score that occurs most frequently, you'll see that this particular 20s occur 6 times, while the other ones occur less than 6 times. So this is your mode, this is your median, and this is your mean. Now you are trying to look if there is an outlier. An outlier is simply an abnormal score. You can see that in this class, most of the time, the age is between 20 to 24, and then suddenly you have 65. Now the problem is that when you are computing an average takes this into account. It's imputed in the calculation, so it's going to distort it. If you have a very large outlier or abnormal score, it's going to affect the mean. However, you are simply looking at the middle score. So this value does not affect what you are doing here. However, for the mean, the outlier, which is this, affects the computation of the mean. So whenever you have an outlier, most of the time we will go with the median. Now let's graphically show what we are talking about. So here, for example, you can see, if you look at the frequency distribution, we have initially in lecture 1, the first part of this lecture, we saw how to generate the distributions. Here, if you do the distribution chart, you can see where 65 is. It's clearly an outlier. However, you can see this outlier is pulling the mean towards itself. So it's not a good measure of central tendency because of the outlier. So in real life, at times, we get rid of the outlier so that it will not mess up the mean. However, the median in this situation is a much better measure. So here we simply declare, in this case, it appears that the median best describes the data set. We'll talk about this again in class. Now let's take a look at some computation which can be a bit tricky. So I'll do that in the next video.